So following on from the previous video, if you get a graph plotter and plots y equals 2 to the power of x, you will get this red line here. If you get a graph plotter and plot y equals 3 to the power of x, you will get this blue line here. Now, if you look at the red line here, y equals 2 to the power of x, if you differentiate it, it will give you this thing here. So when you differentiate this, it will give you some constant times by 2 to the power of x. And this constant here is really the gradient at x equals 0 of the red line. Okay, so that turned out to be roughly 0.69. And then if you look at the y equals 3 to the power of x, if you differentiate it, it will give you some constant times 3 to the power of x. Now this constant here is the gradient of the blue line at x equals 0. So it's going to be this gradient here, and it turned out to be roughly 1.10. Now, we're now going to guess y equals 4 to the power of x. So y equals 4 to the power of x. We're going to guess the graph to look something like this. Okay, so you can see that. If you start with y equals 4 to the power of x, it will give you, if you differentiate it, it will give you dy by dx equals some constant times 4 to the power of x. And this constant here is really the gradient of the black line here at x equals 0. Now, if you look at the red line here, you can see that the gradient is quite shallow here. The gradient is quite shallow. It's only roughly 0.69. If you look at the blue line here, the gradient of the blue line here is steeper. It's steeper than the red line. The gradient of the blue line is 1.10. If you look at y equals 4 to the power of x, the gradient here is a lot steeper than this red line here, and it's steeper than the blue line here. So y, well, you can see that as you increase the base here, the base is 2. The gradient is quite shallow. If you increase the base here to a 3, the gradient gets steeper. If you increase it to y equals 4 to the power of x, the gradient will be even steeper. So as you increase the base here, the gradient gets steeper and steeper, meaning that this box here gets bigger and bigger. So in the case of y equals 4 to the power of x here, this gradient here is steeper than this one, and it's steeper than this one here. So if you look at this here, the gradient of the when it's 2, when the base is 2, the gradient is less than 1. When you look at in the case of the base being 3, the gradient is above 1. So there must be some sort of base in between the two where the gradient is dead on 1. There must be this base here somewhere where this box here is 1. You see, we want to deliberately find a base here where the gradient would be 1. So hang on. If you look at this, y equals a to the power of x. When you differentiate it, you would get this thing here. Okay, so this thing here, this box here, represents the gradient at x equals 0. You see, we want to deliberately find an a here. Well, if you we want to deliberately find a base here where this box here equals 1. We want to deliberately find a base where this thing here equals 1. So when you look at the graph here, if you look at the graph here, in the case of the base being 2, the gradient is less than 1. In the case of the base being 3, the gradient here is above 1. So there must exist a base somewhere in between where the gradient is dead on 1. And it's going to be between 2 and 3. So there's going to be a base where you're going to have y equals a base to the power of x, and when you differentiate it, this box here equals 1. Sorry, not this box here. Hang on. There's going to be a base. So like you have y equals some base here to the power of x. When you differentiate it, you will get this. Sorry, I made a mistake earlier. When you differentiate it, it's going to be some sort of number here times this base here to the power of x, and then we want to find a base. We want to find this base here where this thing here, where this thing here is dead on 1. Don't forget, the base here will affect this box, and it will also affect this box here. So you want to find out a base here where this thing here will be 1. So hang on, let me start again. This bit is quite confusing. Let me re-explain that. So when you have a base here 2, you will have a gradient of less than 1. When you have a base of 3 here, you're going to have a gradient of above 1. So somewhere in between, the base is going to be in between 2 and 3 here, where the gradient will be dead on 1. And the reason why we want, so hang on. So when you start out with this, if you differentiate it, you will get this here. Okay. So hang on. So oops, hang on. So hang on. If you start out with y equals x, y equals some, well, we want to search for a base where if you start out with y equals something to the power of x, when you differentiate it, it will give you this here. So we want to search for a base, and remember, this base here will directly influence your gradient, your dy by dx here. It will directly influence this box, and it will directly influence this box here. So we want to choose a base where this whole box here equals 1. We deliberately want that to be 1 because it really simplifies things. So we want a base here, and don't forget, this base here will influence this, and it will influence this thing here. But the thing is, you want to select a base here where this thing here equals 1. Okay, so when this equals 1, there is a base here. When you differentiate it, it will give you this. But the thing is, you want to choose a base here where this whole thing here equals 1. And when this thing equals 1, then you can actually say dy by dx equals itself. So that means, what that means is when you there exists a base where when you differentiate it, it will be itself, if that makes sense. So hang on. Let's start again. Sorry, hang on, bear with me. So y equals 2 to the power of x. The gradient, this block here will be 0.69. In the case of the base being 3, it would be 1.10. So somewhere in between, there must be a base. There must be a constant somewhere in between where the gradient will be dead on 1. So this base here will be 2 point something, but it's less than 3 to the power of x. And then you, well, when you different, well, hang on, bear with me. You want to search for a base here where it will where this block here will be 1. Well, we don't know what that number is. It's going to be between 2 and 3. It's going to be in between those two numbers. Let's just call it e. Let's just call that constant e. It's going to be a number. We don't know what that number is. Let's just call it that. Let's just say that number is e. So when you differentiate it, it will give you this. Okay, and then that there would, if you can find that constant e, then this whole box here will be 1. We want to deliberately, we don't know what that number is. We don't know what this number is, this e here. We want to find a base. So here, when it's 2, this is going to give us this here. Well, when it's 3, when the base is 3, it's going to give us 1.10. We want to find a base here. We don't know what that base is. We're just going to say that base there is e. Okay, so when you have y equals 2 to the power of x, this block here will be less than 1. When you have y equals 3 to the power of x, this block here will be 1.1. But then when you have y equals e to the power of x, then the block will be dead on 1. So hang on, bear with me. So what that means is, hang on. So we are searching for a base here. When you differentiate it, this whole box here will be 1. Well, let's just say that base there is e. We don't know what the precise number of e is. We just know that it exists. So when you select when you can find a number e, this thing here will be 1. So when this thing here is 1, then you're going to have 1 times e to the power of x, meaning when you differentiate it, meaning that when you differentiate it, dy by dx, it will just give you ex. So that means you're searching for a base here where when you differentiate it, it will be itself. So just this is actually quite important. So you are searching for a base here. When you differentiate it, it will give you itself. Okay, so this here is very important here. We don't forget, we don't know what this number, what the precise number is. We just know that there exists a number where when you differentiate this will be itself, because normally you differentiate it, it will be something times by itself, and we deliberately choose y equals some base here where this block here equals 1. So that well, I will elaborate more on it next time. So yeah, so you're really searching for a base where when you differentiate it, it will give you something like this here, will be some constant times the base to the power of x, and then there, you want to select a base where this block here equals 1 basically, and when this block here equals 1, then it would just be itself, e to the power of x. So e to the power of x, even though you don't know what the precise number is, there exists a base where when you differentiate this, it will give you e to the power of x. Okay, I will elaborate more on it in the next video.